All right, so just summarizing again what we talked about a few minutes ago on the previous video is we're trying to get you to understand the relationship between standard deviations above and below the mean and what a z-score is. So look, in the middle of the graph, this is the mean, mu. That's the symbol for mean. Mu plus rho, there's really a 1 in front of that rho, and rho stands for standard deviation. So that's the mean plus 1 standard deviation. Over here on the left, that's the mean minus 1 standard deviation. Going back to the right here to now where it's the border between the green and the purple, that's the mean plus 2 standard deviations. Down on the left is the mean minus 2 standard deviations between the purple and the green. What does this have to do with z-scores? Well, a z-score is a really simple thing to understand. When it says the mean plus 1 standard deviation, we simplify that by calling it 1 z-score. Mean plus 2 standard deviations, that's a z-score of 2. Mean plus 3 standard deviations, that's a z-score of 3. On the left side, if you're below the mean, that's a negative z-score. And in this case, the mean minus 1 standard deviation is a z-score of negative 1. Minus 2 standard deviations is a z-score of negative 2. Minus 3 standard deviations is a z-score of negative 3, and so on. Okay, so let's do this particular question here. We've got 2 more questions to work on to really reinforce these points, and then a little summary slide, a little conclusion slide. Suppose X has a normal distribution with a mean of 50 and a standard deviation of 6, okay? About 68% of the X values lie within 1 standard deviation of the mean. We know that that was that reddish rose area in the normal curve we did before. Therefore, about 68% of the X values lie between minus 1 standard deviation, which is negative 6, right? Because each standard deviation is worth 6, and I'm going down 1. And positive 6 above the mean because it's 1 standard deviation above. If the mean is 50, if I'm 1 standard deviation below and every standard deviation is worth 6, then 50 minus 6 is 44, and 50 plus 6 is 56. So what we know is that 68%, let me click back real quick to this diagram here, and then I'll come back to what I'm working on now. Here we had the mean. We just said the mean was 50, and we said the standard deviation was 6. So if I go down 1 standard deviation, I get to 44. If I go up 1 standard deviation, I get to 56. And here is my 68% right here in this rose area, 34 plus 34. So 68% of the scores are between 44 and 56, okay? So that's important to be able to understand. So here we are, okay? That's where they're getting the z-scores are negative 1 and positive 1, and the z-score for 44 is a negative 1, and the z-score for 56 is a positive 1. Now, if I go out one more level between where the green and the brown met on the graph, that's about 95% of the scores. So that's down 2 standard deviations and up 2 standard deviations. So if I go down 2 standard deviations and each standard deviation is worth 6, that's minus 12. And if I go up 2, that's plus 12. Well, remember, the mean is 50. That's in the middle. So 50 minus the 12 is 38, and 50 plus the 12 is 62. So 95% of the scores are within 2 standard deviations of 50, which means you are within X values of 38 and 62, and the z-scores are negative 2 and positive 2, okay? And about 99.7% of the scores are within 3 below and 3 above. So 3 below is negative 18, 3 above is positive 18. So if I do 50 minus 18, I get to 32. And if I do 50 plus 18, I get to 68. So 99.7% of the scores are contained between 32 and 68. So let's apply that to parts B and C here, okay? Not part A. You're going to do on your homework this exact same scenario, but you're going to do part A. I blocked it out for now, okay? So what we have here is from 1984 to 85, the mean height of 15 to 18-year-old males from Chile was 172.36 centimeters, and the standard deviation was 6.34 centimeters. So the average height is 172.36, and the standard deviation is 6.34. That is noted in this notation right here. Okay? Y tilde, and for normal distribution, the mean is 172.36, standard deviation is 6.34. About 95% of Y values lie between what two values? Now, the part you have to remember is the 95% is between two standard deviations below the mean and two standard deviations above the mean. So we start with 172.36, and then I do 2 times 6.34 and subtract it from 172.36, and then I add it to 172.36. And that tells me what the scores are between. So if I do 6.34 times 2 and subtract it from 172.36, I get 159.68. And if I do 6.34 times 2 and add it to 172.36, I get 185.04. So 95% of the scores are contained within z factors of -2 and +2, which means 2 standard deviations below the mean, 2 standard deviations above the mean. So I come over here, I look at my standard deviations, I multiply it by 2, I subtract it from the mean, that gives me my first number, I add it to the mean, that gives me my second number. How do you think that relates to part C? About 99% of the Y values lie between which two values? I'm going to give you, you do a little stop and start here, but you try to answer this question and then I'll go over it with you. Okay, so this time I'm going to multiply the 6.34 by 3 because I need 3 standard deviations to get out to 99.7%. And then I'm going to multiply 6.34 by 3 and subtract it from 172.36. That gives me the left side of the graph. Then I'm going to add the 6.34 times 3 to 172.36, and that gives me the right side of the graph. If I subtract, I get 153.34. If I add, I get 191.38. Okay? So now what I'm doing is I'm finding the mean, and I'm figuring out the standard deviation. How many do I need to go left and right to get the percentages that they're talking about? 95%, I need to go 2 below, 2 above. 99.7%, I need 3 below, 3 above. The really cool thing is it never changes. Never, ever, ever changes. So if you just either look at a picture of the graph, use it as a reference graph. When I taught this to kids at school, we always, well, we didn't always. We used to have to memorize the graph, but probably about 10 or 15 years ago, they started giving the kids a picture of the graph to help them remember. So you can use a picture to help you. Okay, next up, from 84 to 85, the mean height of 15 to 18-year-old males from Chile was 172.36. We already said this. Standard deviation 6.34. Here we go, listed right there. Then this was from 84 to 85. Then they found the stats changed from 2009 to 2010. And they said, okay, well, this time the average height was 170 and the standard deviation was slightly different. It was 6.28. So both changed a little bit. Both got a little bit smaller. Male heights are known to follow a normal distribution. So in the first case, they called it Y, just so you could tell the two of them apart. It's a normal distribution with the mean of 172.36 and the standard deviation of 6.34. And then for the second one, it's the normal distribution with a mean of 170 and 6.28 as your standard deviation. Find the z-scores for x equals 160.58 centimeters and y equals 162.85 centimeters, and then interpret each of those z-scores. So let's find the x score first. We're going to plug it into the x formula, which is the one over here, x tilde n 176.28. So here's my z-score formula. It's the x score minus the mean, which was 170. So the x score they give us is 160.58. There it is. I put it in. minus 170, because that's the mean, that's the next part of the formula, over the standard deviation, which is 6.28. Maybe I should have really shown you the formula on this. I'm sorry for not doing that, but you've seen it a bunch and you do have a reference of it. And then I just run the numbers. 160.58 minus 170 equals, and then divide by 6.28. You get negative 1.5. So that's the X score. And what this means is that the score is 1.5, 1.5 standard deviations below the mean. Okay, well, let's take a look at the Y now. For the Y score, the Y they gave us was 162.85. And you would think this kid's a little bit taller, and in an absolute sense he is, but when you do 162.85 minus the new mean, which up here in the Y function, the mean is 172.36. There it is up top. See it? Y tilde N. The mean, the new score is 162.85 minus the new mean of 172.36. Get that equals, divide by 6.34, which is the new standard deviation in this particular part. And again, I get negative 1.5. So that means that this score is also 1.5 standard deviations below the mean. So all you needed to do on these problems was plug them into the z-score formulas, and you would see that the two answers are the same, which means relative to the size of a male in Chile in the ages 15 to 18-year-olds at that time, at the eras in which they were growing up, their heights are pretty much the same, okay? All right, so key points to today's lesson, super key points. Normal distribution is a brand new form to data, all right? Probabilities. And it's very different than uniform distribution. You have to notice right away, uniform in those formulas, those notations, and normal, very important. Uniform is a flat rectangle all the way across. The normal curve is a bell-shaped curve, very symmetric, okay? Well, so is a uniform one, but uniform looks like a rectangle. A bell-shape doesn't look like a rectangle at all. The notation X tilde N mu comma rho, which tells us the mean and the standard deviation. The mean is the mu, the first number in the parentheses. The rho is the standard deviation, the second number. They in turn are parts of the key equation, and results are graphed onto this curve. Also remember that a z-factor is how many standard deviations you are above or below the mean. How do you figure out a z-factor? The z-factor is whatever the score they give you minus the mean divided by the standard deviation. And if you listened to me try to explain how I used to do these in my head, my guess is a number of you, most of you, did not follow along because it was a very convoluted way of reasoning it. And this formula, oh, does it make life simple. So do not forget the formula. All right, that covers us through for lesson 12. And we're going to put, after this, some homework questions for you to do. Have a great rest of the day.